Well, it gives me great pleasure to introduce our workshop lead here, Kevin Stack, CEO of Building in Nature's Image. Kevin has been absolutely essential in making today's workshop happen. He came to us with the idea of hosting it here at the Wild Center, which is, of course, the things we like to do, and has really helped to shape the entire day and helped to make sure that this stuff was available. Courses like this are available to folks in the North Country. We don't often get the opportunity to get professional development and have this here today and not have to travel like all the way downstate or out to the western part of the state is so great. So Kevin, we're so grateful for your support and for your leadership in this. And as Kevin said, I am a biologist turned builder, so I'm going to let you describe, let you introduce yourself, and welcome you to the stage. Thanks so much, Kevin.
So just before we get started, how many code officers are in the room? Just raise your hands if you would. So Bernadette, you're supposed to be counting all these guys. And women, 1, 2, 3, 4, 5, 6. So, and builders, about material suppliers. Anyone I haven't named? Engineers, architects, teachers. Oh, good to know. So to put this in context, why a builder is up here talking about energy codes. My journey here began about 5 decades ago. I rode on a hay wagon all the way down, a tractor trailer carrying hay down to West Milford, New Jersey, to apply for a job at Warner Brothers Jungle Habitat. They hired me on the spot. Very next day, I didn't even travel with a suitcase. I had no change of clothes or nothing. They gave me a uniform. They set me in a Toyota Land Cruiser. They had bars on the windows, a shotgun on the seat, and a bucket of horse meat next to me, and put me in a lion compound. So this is one of those parks where you drove through, your vehicle was the cage, and the lions ran free. Problem is, there was about 1.3 acres to 2 acres of compound, and there are 2 different prides of lions there. So kind of like what our world's going through today. That did not fare well with both lions in there, right? So I think there was like 9 in total. So that's where I got my start. And I thought everything was good. I was down in West Milford, New Jersey, and then Syria and Egypt decided to attack Israel. The U.S. backed Israel. OPEC nations started the first oil embargo. So when I was down there, I waited in line for 9 hours to get gas. Those of you in the room who don't remember, you were getting gas on odd, even, the last numbers on your license plates. So if you had an even number at the last number, you could get gas on Monday, Wednesday, Fridays. If it was an odd number, Tuesday, Thursday, Saturdays. Sundays, you couldn't get gas. So why am I bringing that story here today? Because after waiting in line for 9 hours, I couldn't get gas because my license plate was New York State, and I was living in West Milford, New Jersey. So I had to walk to work. 2.5 weeks, 7 miles before my colleagues saw me walking to work and gave me a ride. So I learned the hard way about the energy crisis, and here we are 50 years later, and we're going through the same thing, right? Same players, same issues. Oil prices are up. Back then they went from $3 to $12 a barrel, and now they're up to over $100 a barrel, right? So that's where I got started. So it's we're going to talk about these 2 books here, and they're contained right in these books. Here's the 2020 code. Here's the new one, the 2025 code, and it lives inside the book that Art's going to talk about later, in chapter 11. So this is a picture of where our office sits up on top of this hill. If you look down here, if you think about it for a minute, our buildings really are alive, and you do create a lot of emissions, right? I think Chris just proved that when I looked at the slide up there, how many houses are still on either oil, gas, or in some cases coal, because there's a coal-fired power plant in the far back right of that picture. So if you look at this and you start thinking about what really happened 5 decades ago, well, actually it was a quiet marine biologist named Rachel Carson. When she published her book, she took on the chemical industry and parts of our government, Silent Spring, but she won. And that was the start of everything we need to know about energy right now. And it actually was the first code, the energy code. Our first energy code was ASHRAE 1975, and it was created because of that war that got started way back when. And so we fast forward and we're 50% better now. But our goal in New York State and the country right now in that glide path is actually 0 by 2050, right? So this is getting pretty aggressive here. So a couple of things I want to talk about also. Well, I guess we do have to go through the learning objectives very quickly in order for us to get credit here. I don't have to read it, but you guys can take a look at it. And so we talk about all electric homes, right? Our governor has just pushed back all of this, rolled it back another 10 years, so it's no longer 70% emissions reduction by 2030. It's going to be by 2040, and the 2050 deadline's probably going to go to 2060 because we just can't get there. So this is back in 1949. This is actually my grandfather's house. And he built what I would consider one of the first all-electric homes way back then. And if you look at the outstanding features of the home, it's pretty much what we have today. So have we really progressed that far? I'm not so sure. This is what an all-electric home looks like today. This is a house my son built, and it's net zero energy because it's hooked to community solar. And that's community solar on the right. That's looking down from the hill where I live. And that's pretty much what it does look like when the sun hits the solar panels. So some of the complaints about solar fields are true. The glare is really there. But this is an all-electric home. So this was built in 2023 on the shores of Skaneateles Lake. This morning I went to the New York Independent System Operators website, and this is the power where we're getting in New York State right now. This is all fuels in New York State as of 8 a.m. this morning. See where hydro is. Hydro's been there for about, I would say, for the last 20 years at about 20%. It was actually one of the big things when Andrew Cuomo would stand up and say we have the best renewable energy in the nation, but it was all because of the hydro, and we know all where the hydro comes from, right? Well, if you look at what's the part of the renewable side, hydro's at 64%. Yesterday morning, it was 20% less than that. So you can see what the oil and gas prices are doing to us right now, right? We're coming to rely and pull more of our energy in New York State with basically hydro, and you can see where wind actually jumped up a lot. That's strictly New York State. Well, we are getting hydro from, you guys know that the line's running down the Hudson River right now in New York City, right? That's in play. That's the power coming from Canada. Good question. Geothermal, and I believe nuclear was already up there, right? Nuclear is in there. Yeah, there it is right there, 12.75. So in December 16th of 2025, that's not that long ago, there was a unanimous vote that accepted the New York State Energy Plan as an all-the-above approach. So the New York Independent System Operator slide that I showed you is probably going to be what we're going to be seeing for quite a while now. This is the same slide that Chris showed, but I want to make important, I think this is a laser. You look at the IECC, it's all based on the International Energy Conservation Code of 2024. If you look at that, you can say, okay, we've only reduced our energy efficiency in this code by 6 to 8%. Is that true? Not. And this is where we're starting to hear these things that over and over again. But in New York State, we do things differently, right? Andrew Cuomo, again, way back in 2006, skipped to 2009. We hit that code, and then we went right to the 2015 code. That was a 20% energy reduction in a simple code change. So where are we now? If you look at, we didn't do started with, I don't have a laser here, but if you start backing up the graph in the dark line there, see the 2015 code to the 2018 code, and now we just adopted the 2024 code. So we skipped the code cycle of the 2021. So if you add those numbers together, we're much closer to about 17 to 19% energy reduction. That's where we are right here today. And that's important. This is the first code cycle ever that's introduced two more performance tests. 2015 was the first ever code to introduce the air leakage test, the blower door test, right? How many are familiar with the blower door test in here? So everyone's doing them for your certificate of occupancy? Because it's required, right? It's mandatory, it's not should, it's shall. All right, so when we start to look at these codes, we start to see what's really happening, right? There was no grace period, again, no transition period. We immediately went on December 31st of 2025. At that last hour of last year, any permit that was pulled after that had to go into the new code. This is what the code books look like. It's a common misconception in that everything is included in the code books and online, because it's not. The Uniform Code is actually contained in 19 NYCRR parts 1,220 to 1,227. And we need to know that, because it's really the prescriptive stuff that's embedded in the website that tells us a lot of stuff that the code books aren't telling us. It's telling us about not just what we have to do, but why we have to do it and how the code was created and what we need to follow. And before you look at any code book or any online forums, you have to go to that website, because things change, right? When they make a decision to change something, maybe the code wasn't written properly or something else was different, or they decided to upgrade it or downgrade it, you have to go with the app, what's going on right then and there, and match it up with when that permit was pulled. And it's not the only book, right? I think we're all well aware of this. We're only teaching from two code books today, the Energy Code and the Residential Construction Code of New York State, but there's many, many other books that are referenced in each code. And the other important part about references is a lot of people don't understand, especially us builders, is that when something is referenced or stated in a code book, like a standard like ASHRAE, or you must follow the manufacturer's installation instructions, that becomes part of the code. That becomes the law. So manufacturer's installation instructions do actually mean a lot today. Whatever is more strict, that's what you got to go with. The only thing we're not allowed to do in a code book, we're not allowed to reduce the federal appliance standards. That's something that's untouchable. So in 2006, that's an important date, because we're going to talk a little bit. We're 2 hours here, so I'm going to go back and forth on some of this stuff. But the referenced home that's buried in the code, whether it's the energy rating index or the simulated performance path, is based on 2006 International Energy Conservation Code. Because how do humidifiers work? They blow air across little bodies of water, right? In our furnace or our air handling systems. That's all they do. So what we decide to put into our homes for insulation, building envelope, and air leakage, air barriers are pretty different from when we build up on the top of a hill in Manlius, New York, or on the shores of Skaneateles Lake. Hydroscopic building materials are not good when you're sitting right next to a largest humidifier in New York State, right? So this is what New York State looks like. You know, the climate zones haven't changed that much, or have they? Because look what we just did. We just moved 8 counties out of Climate Zone 6 into Climate Zone 5. 8 different counties. And all that movement is based on heating degree days. Nothing else. That's all it measures. Heating degree days and cooling degree days. Imagine that. It has nothing to do about the wind loads that Art is going to talk about or anything else. We just slid 8 different counties into Climate Zone 5. And that's going to get pretty important, because in Climate Zone 6 this year, it's the first time ever an HRV or an ERV is required. If you're building in climate zone 6, you have to have a heat recovery ventilator or an energy recovery ventilator. And it has to be set to an ASHRAE standard, ASHRAE 62.2, 2018. And that's going to change. And that's the standard that's referenced in the code book that will change outside of the code book, but it will not change until the code catches up to it. That's important to know. When we talk about ASHRAE 62, it's a simple formula, right? It's 0.3 times the condition area of the home, which you can get right off the building permit, plus the number of bedrooms in the house plus 1. So what does all that mean? Why do they say a number of bedrooms in the house plus 1? It means in the ASHRAE standards that they're considering that 2 people are in the master bedroom and every other bedroom has 1 person in it. This year alone, for the very first time, the code cycle decided that 5,000 square feet was a big house. But let's say that the code is telling us, because it referenced ASHRAE 62.2, and there's a chart in the code book so you can look up the number of bedrooms, square foot, and it'll tell you how many CFMs you have to introduce. Mandatory introduce, not should, it's a shall. How often in these big houses that you guys see that's 5,000 square feet, do you see 6 people living in that house? How often are they actually in the house up here in the Adirondacks? Not often. So we have a code that's telling us what the air changes have to be in that house, mechanically ventilated in that house, that's based on a standard that was created 50 or 60 years ago, but doesn't necessarily do justice to the house. So I still work with a hammer. I don't work with a computer, so I'll be the first one to tell you, our houses do not live inside computer models. They don't. And so when they start to underperform, this retro commissioning that a lot of us do becomes critical. Because you got to understand how the house is actually being used. It can't be based on a standard. If we're over-ventilating a house that's, let's say, 5,000 square feet, or even let's say a 3,200 square feet house that has 4 bedrooms, that's 5 people that they're ventilating for. That's energy that's being used. Now put that house in climate zone 6 when you got a heat recovery ventilator or an energy recovery ventilator. What's happening? We're using energy. We set it and forget it, right? Because us builders don't go back in there. We set it to 62.2 and we walk away. Now we have a winter like we just went through, and we have relative humidity outside that's, I don't know, 12%, maybe 19% at best, and we're bringing all that dry air into the house. And again, here's the builder side of me talking. We just violated every manufacturer warranty on our millwork. Our hardwood floors shrink up, our millwork starts to move, and everyone says, oh, the builder's fault, right? Well, we only did what the code told us we had to do. Today's code, as the first of this year, we have to measure the mechanical ventilation. Who gets to do that? Code officials are going to buy a barometer and hold it up there and measure how much air is being exhausted and supplied to that house? You guys are overworked, underpaid. I know this. I know many code officers back where I'm at. How are you going to find the time to measure it, to make sure you met the code that's mandatory? And then how do you go back when you hear from a homeowner and say, I got a $300,000 millwork package and it's all shrinking up. My floors are shrinking up. Call the manufacturer, call the installer, and they say, well, I got a relative humidity meter in my hand. Your house is at 20%. Manufacturer's instruction says if you're not between 45 and 50% or 55%, it's all yours. You just violated the manufacturer's warranty. I don't have to do anything. The builder's on the hook for it, right? So we got to start thinking differently about what's in the code books. Our houses no longer live inside of a computer. They're actually being lived in by real people, and we need to know the number of people. So when we get these complaints, they're easy to write off, but retro-commissioning should at some point, at least hopefully in my lifetime, get to a point where it should almost be mandatory for someone to go back in and set the house to how it's actually being used. Otherwise, we're just hurting ourselves and we're using more and more energy. And the code cycle's on a glide path to 2050 to be zero emissions and get our energy down to zero, right? So we're kind of moving back and forth here. So we're in a room that we have no way out of right now until the code starts to change, right? Okay, so if you guys can make it out in green here, these are the 6 counties that slid down from climate zone 6 to climate zone 5. That's a big thing because no ERV or HRV now, they don't have to put it in. Other parts of the code are different too. Here's the phenology. It's a biological term, I'm sorry, but that's how I got my start in life. And you see how it changed from the 2020 stretch code. Actually, you can see it kind of flopped right over in the 2025 Energy Conservation Construction Code, right? Pretty darn close to happening. And it also, if you start to look at this next slide here, some of this stuff you can get online, so it's not a big deal. But if you start to look at this, the 2024 International Energy Conservation Code really took everything from climate zone 6 and put it in climate zones 4, 5, and 6. It is the first time ever in a code that I'm aware of where a metric went down. And what metric is that? Can you guys see it up there? It's a big one. It's the ceilings. R49 across all 3 climate zones in New York State. What it used to be? R60, right? So what do you think happened there that the code that's supposed to be on a glide path to net zero just made that change? Well, the wood framed walls are something we're going to talk about a little bit because it's actually wood framed walls and the windows are big things in the code. Josh and I get 2 to 3 calls a week on what are we going to do with the windows. We like to use Marvin Ultimate and they don't make a window that meets the intent of the code. What do? Go to the ERI path. The backstop on the ERI path is like 0.4, not 0.27. You can get there if you start to manage and use the code to your benefit, right? So the big thing here is that the R49, the reduction was because the building scientists proved in a simple flow chart, XY axis, that after R49, the return on an investment was 2 to 3%. The other thing you start seeing, we're going to talk a lot about duct leakage, because that's a massive change in the codes right now. Okay, so here's the significant changes. Framing and air barrier inspections. How many knows what an air barrier is? Everyone knows what it is, right? Can you walk outside this building today to a new construction and identify the air barrier? Because I can't. I'm a builder and I put them in. I'm also a HERS rater that have tested over 1,000 houses, probably thousands by now. And when I put a air leakage test in there and put my blower door in, that air barrier is not where it said it was on the print. Very rarely do I find it there. Do you know where we get the most air leakage when we do our air leakage test with a blower door? We don't even have to do the forensics. The zonal pressure diagnostics where we can put a tube into the ceiling and find out if the attic space is connected to the house. Put it in the garage. Where's your air barrier in the garage? Not Tyvek house wrap, right? It's the drywall. And it only has to be fire taped, right? And do we do as much air sealing in our garages as what we do in the rest of the house? Not even close, right? And what do we put in our garages? Everything we don't want in the house, right? Cans of oil, cans of gas, our car, our lawnmower, old paint products, everything that's going to outgas with high VOCs that actually do react in the atmosphere and cause harm. Well, if air barrier is broken in the garage, that's a bad thing. How do you inspect for an air barrier in a garage when all you got to look at is drywall? That's it. You can't see around the base, but where your mud sills hitting your concrete blocks or your concrete wall. So the next area, biggest area leakage, it's not the ceiling. It's usually that perimeter of the base. Where you have a wood product that hits a concrete product. Concrete doesn't move and the wood's moving, right? We put this thin thing of foam down, and next thing you know, we're finding we're getting a lot of our air with exhaust-only ventilation. Or let's say someone turns a dryer on. Do you know a dryer exhausts 250 to 300 CFMs per minute? Big exhaust every time we use our dryer. We find that it comes underneath our decks, low to the ground. What do we find underneath our decks? Poor air quality. So the code is telling us that we have to do mechanical ventilation. We have to test it. We're supposed to know what the quality is. Anyone in this room can tell me what the quality of air is? Because the code says that in the technical bulletin. You got to measure the quantity and the quality. I don't know how you do that. I can't do that unless I go to Syracuse Center of Excellence and borrow one of their $60,000 machines and put it in the house and see if I get a particulate counter to see what's coming out, and then go grow it in a petri dish and find out what's really coming into our house. So air barrier is critical. That's an inspection, so the code officers that raise their hands in this room, it's no longer a framing inspection, it's a framing and air barrier inspection, and that may take 2 trips, right? When you're looking at the framing, sometimes the air barrier is not in place yet. It's not there. So when are you going to get a chance to see that before they put the air barrier on and the siding right behind it? Because a lot of builders will do the air barrier with the siding, right? Or maybe it's SIP sheathing, who knows? It's supposed to be identified on the plan. The plan that you guys do, your plan review in the office before you issue your building permit is supposed to be signed. 3 plans, you keep one in the office, the builders shall, mandatory, keep one in the house with your signature on it. So when they show up, they have the same plan to look at, the one that they approved in your office how many months before? 6, 8 months, 3 months, 3 weeks? It doesn't matter. It should be there, right? Prescriptive compliance option. We're going to go into this one a lot. Josh is going to help me on this one. It's additional energy efficiency measures, brand new in the code, right? It's not on ResCheck. You have to manually enter and write it in on the ResCheck form and print it out. So ResCheck can do a lot of things for us. And yeah, by the way, this code cycle came into play January 1st of 2026. ResCheck didn't even have a drop-down box till 3 weeks ago for the 2025 Energy Conservation Construction Code. Who did those plans review? I have builders calling me up, hey, we checked the 2024 IECC and we got our permit. There's no way. They're not the same. They're not the same. But now we have the drop-down box, and there is a place to write in, the architect or the engineer, or whoever does the res check for you, can write down those extra energy efficiency things. But there's a checkbox for it. And they've got to do 10 items from 2 categories. And oh yeah, if your house is over 5,000 square feet, you got to add 5 more energy efficiency items.
Points.
So I think you're going to, Points, yeah. So when you do that, think about it. I mean, if I was an architect, I'd come in at 4,999 square feet, right? Probably. It's a smart move for an architect to do that, to get his plans reviewed. Insulation and fenestration criteria, that's changed. That's in the prescriptive part. The component performance alternative. Imagine that, a brand new name in the code. How come? Why did they have to change the name in the code just to screw us all up? We thought we had it, right? We knew the charts. We know the our 402.1 and 1.3. We knew it, but now they had to change it because the first time in the code they said, we always had a factor in there for concrete slabs, but it was always wrong. So now you have to include the F factor. That's the heat loss from the slab. And it's not just the slabs on grade. There's if you're going to use ResCheck, or if you're going to do the ERI path, or the simulated building performance path, or if you do the prescriptive pass, you have to account for the loss of heat in the slabs. Because it's been proven over and over again, there's more heat loss there than you can imagine. So there's a number in there that you're going to put in when it's less than 12 inches below the ground, let's say a walkout basement, but as it wraps around the house, and if it's only 4 feet below grade, there's a number in there that you put in, a correction factor, and if it's 8 feet below grade at the top of the house where the entry is usually, it's a different correction factor. The models do that for you, but if you're going to do the prescriptive path in a different way on numbers 1 and 2, you've got to do that, right? You have to do the math on that. Climate Zone 6, we already talked about the HRV, ERV, but oh, look at that. They just lowered the air leakage test to 2.5 air changes per hour in Climate Zone 6. Thank God those 8 counties got moved out, right? A lot of them, we do 2 or 3 a week, the air leakage test for other builders so they can get their certificate of occupancy, and sometimes they're barely making it at 3. Now they get it at 2.5. And if you select an energy efficiency measure out of the other additional measures where you're reducing the total conduction in Climate Zone 6, they put a backstop in. You can't get an air leakage test below 2 ACH 50. So you're 2 to 2.5, that's your metric for passing if you select that one box. Better be very careful what box the architect checks for you guys, because for you to be in that fine line with all you're doing is measuring the air leaking out of your room, that's a big thing, right? So is everyone familiar with the air leakage test? Everyone? Some nods, you know. Okay, it's like if this was your house, I'm going to go through this real quick because a lot of people don't understand it. We just put a big fan on that door. And there's a micromanometer we hook up, and all it does is measure how much air is going out at minus 50 pascals. Minus 50 pascals is like putting a 20-mile-per-hour wind on your house. So it's normalizing all the background leakage, and it's getting to a point where I can test a house here in Tupper Lake, and I can compare it to a house out in Seattle where my daughter Jill lives, Seattle, Washington. And we can look at the same metrics because everything's normalized. So we depressurize this space with respect to the outside, minus 50 pascals, and we're just measuring how much air leaks out. That's it. We know what the air volume is. We can measure it, you know. Length times width times height gives us the volume. That's the denominator. So high school math, right? If the denominator is bigger, we're going to have a lot less lower for our air leakage, right? So that's why a lot of architects like to include the basement. If it's conditioned, they'll include as much space as they can because the bigger you get the denominator, the easier it is to pass the air leakage test. The critical issue is in those 5,000 square foot house, lots of volume, easy to pass. Small, tiny houses, if you go to any of the rating system programs, whether it's LEED, National Green Building Standard, Passive House, Living Future Challenge, Energy Star, it doesn't matter. They change the metric, so they make it easier for smaller houses to pass because it's so hard. So the other thing is that the day is going to come, and mark me on this one, where we're going to throw that metric out and we're going to start measuring what we really need to measure. How much air is lost on the envelope, on all 6 sides of the envelopes. That's what we do in the multifamily world right now. We don't measure how much air leaks out of the unit. We're measuring how much air is leaking through the building assembly. Air barrier assembly, right? And the other thing that a lot of people say, they brag about their air leakage result. Oh, I got one. Well, they shouldn't be bragging about that. ACH 50 is that it only measures air. It's not measuring any thermal characteristics of the house. It only measures air leakage. Very rarely can you identify, unless you've got an IR camera or a smoke test, can you identify where that air is leaving. And when you do, I'm going to go right back to it's usually coming in from the garage or beneath your decks. We're bringing in bad air. So it's only measuring air, and that's the metric we got to go with. Duct system testing, holy smokes. If my grandkids weren't here, I'd probably use a different word, because I don't know if you guys know much about duct leakage testing, but I've been doing it for 28 years now, right? It's not easy. It's difficult. And if the builders are in the room, if they've never had their ducts tested before, they better do a pre-drywall test so that you're not taking the drywall off the walls, trying to find where these air leaks are, and thinking that, oh, I'll just spend the $3,000 or whatever it is to get air barrier and I'll blow these particulates in there and they'll seal it up. They only seal up the small leaks, not the big ones. You gotta be very careful with the duct leakage testing. We talked about the additional efficiency requirements, prescriptive path only, not in the ERI path or simulated. And then I just put in there the solar ready zone inspections. If you put one in, then you have to do it. But all those appendices were rooted out of the International Energy Conservation Code. There's like 7 of them that were built into the code, got passed, then on appeal were all taken out. What New York State allowed to do and the 2024 IEC allowed to do is they put those appendices in the code book so that any state or municipality can yank them out and make them part of the code if they so choose. The only one that New York State adopted was the RF one. RF stands for residential fenestration, but the only reason it's there is because there's the chart for the F factor you have to use to put in your models. You have to measure the heat loss from your concrete slabs. So here's the 3 pathways. I mean, this is actually on the exam when you take a plan reviewer test with ICC or whatever. There's 3 pathways for compliance. Our 40121 prescriptive compliance option. There's 3 ways you can do it. It's simple prescriptive. You have the U factor chart there, and the U factor for your assemblies and for your fenestration. You just do all that. You pass the code. Simply prescriptive. There's section B there, minimum R values by fenestration. Same thing. All prescriptive. And C, the performance component alternative, the one they changed the name of, because no longer is it a component. They threw the F factor in, which is not a U value. They're not even close to being the same. You measure heat loss from a slab completely different than you measure through the glass or through a piece of insulation. So if you start to think about this, they couldn't say it was a component. So they had to change it. They had to change the UA approach to the component alternative. And that's what's now in ResCheck. That's usually the most often used compliance path. Then you have the simulated building performance. All it's doing is comparing the cost, the energy cost, based on one that the reference home that lives inside a computer. And if you're better than what they are by a certain percentage part, and it's like 20% for if you, so here you go. Here's the code sneaking in electrification. If you have a fossil fuel appliance in your house, you have to have a 20% reduction. If you're all electric, let's say air source heat pumps or geothermal, it's only a 15% reduction. So they're sneaking it in probably about 5 or 6 places here that unless you read this code book quite a bit, you don't even know it exists there, but it does exist. So the simulated performance doesn't include lighting. It only includes your heating, cooling, and ventilating. That's all the costs they're measuring right now. And if you can beat that, you got it. I would say the most often one that is not used now, the energy rating index. I mean, we should have been using this for the past 20 years because 45L was that federal tax credit that gave you $2,000 if you hit the mark right now that we have to hit, right? Builders didn't want to do it because you had to do all the other testing. You had to do the air leakage test. Well, 2015 code, got to do the air leakage test. You had to do the duct leakage test. Well, 2025 code, you got to do the duct leakage test. You had to do the mechanical ventilation test. Well, 2025 code, you got to do the mechanical ventilation test. We're there. The 45L tax credit sunsets in 3 months. It was a $2,000 federal tax credit. I have a friend in Wisconsin I used to go to a lot of these HERS Raider conferences with. Built 40 houses a year. The tax credit, not a deduction, right? If he had a tax bill at the end of the year was $100,000, 40 houses times 2,000 is $80,000. He only owed $20,000. And still builders didn't do it because they didn't want to pay the cost for HERS Rater. Well, you're doing what the HERS Rater does, everything except the modeling you're doing. And guess what the modeling can do? I'm getting a little bit ahead of myself, but I can't impress enough. I think there's 55 solutions in this room. Where'd that guy go? There he is back there. I can't impress enough that my son Josh is sitting here. He's building on Casanova Lake, high-end house on Casanova Lake. He calls in for an insulation inspection. He doesn't get a call back for 3 or 4 days. He wants to get the drywall up. Time is money. You got a drywaller scheduled, you better use them, right? He hasn't even gotten a call back yet, so maybe he'll get an insulation inspection next week, right? That's a municipality that can do what they need to do on their schedule. If you hire a HERS Rater, but here's the key, it doesn't have to be a HERS Rater. You want to get the tax credit in the next 3 months, it has to be a HERS Rater. But do the energy rating index, it does not have to be a HERS Rater. It can be anyone the authority having jurisdiction, you guys, says can do that. Think about that. If I'm a builder and I sign a contract with a person who can do that, and in that contract I say you got to respond within 24 hours, it changes the whole metric. And the other bigger metric is you got a third party. It's not first party, it's not second party, it's a third party who's totally independent that looks at your insulation, inspects the air barrier, does the air leakage test, does the duct leakage test, does the mechanical ventilation, signs it, hands it to the building official, and you're all done. And when the 45L tax credit comes back, which it will, you'll get a $2,000 incentive for that. A HERS Rater today, I don't know what they're charging. I really don't know. It's been a while. My HERS Rater number in New York State was 001. So I've been doing this since 1998, and I would say back in the day, we got the largest builder in the Northeast, and I did this as like a part-time job as a favor for them. I made $70,000 working nights and weekends just doing this testing, right? And I was only charging like $300. I think today they probably charge, I don't know, $600-800. That's not bad. You got a third. How much is it, Art? Yeah, there you go. They have a third person come in. When you call them, I need you there tomorrow mornings to check my air barrier, my insulation, or do my blower door test, my air leakage test. Because remember, you can't get a certificate of occupancy until you give that air leakage report in, right? You can't give it to them. You can't even give them a TCO without it if they're going to live in that house, right? So energy rating index is different than the HERS rating, but it uses the same scale. Maximum assembly U factors and fenestration. So here you go. If you start looking in there, there's an F factor buried in there somewhere, but if you start to look at it, the other thing about the code that may screw you up a little bit, there are so many things on the left side. Remember, the left side used to be the top, and the climate zones were down on the left column, vertical column, and the components were across side. They changed it. So now it's easier for us to read. So you can go right across the top. This is the prescriptive side. The fenestration is 0.27, all climate zones. The skylight, we won't go through that. Glazed vertical fenestration. The solar heat gain coefficient is in climate zone 4. This is one that, I think the code officials had maybe 1,000 things, and hey, you got it wrong. So look at that, third one down. Glazed vertical fenestration, solar heat gain coefficient, 0.40, climate zone 4 only, nothing else, right? Let's go to this one. Oh, look at that, third one down. Climate zone 4, 0.40, climate zone 5, 0.40. Why the difference? What happened there? Is it an error? Not, because we measure the resistant, the R, different than we measure the U factor. Even though they're the inverse, you can go from an R value to a U value just by dividing by 1, right? Because they're the inverse, but they're computed differently. So if you start to see these prescriptive charts, you better know what you're looking at, because in climate zone 5, we do have a solar heat gain coefficient. Whoop, I went the wrong way. Of 0.40. So now you're talking to the window manufacturers that prescriptively say, I don't have a window, my highest end window, I'm just going to use Marvin Ultimate because I get more calls about that than anyone else, that meets the 0.27. But now, if you use that other part of the prescriptive code, you got to put the solar heat gain coefficient in there. And for everyone who knows about windows, the solar heat gain coefficient and the U value change with each other, right? When you start lowering the U value, you're raising the solar heat gain coefficient. Simple physics. Wood frame walls. You know, we got, you guys can rate it across R30 in climate zone 4. If we sneak over, they're all the same. Right across the board, climate zone 4, 5, and 6. How do we do that? How do we get an R30 in a wall assembly that's, say, a 2x6 wall assembly? Can't do that. Can we do 20 plus 5 continuous? And continuous insulation on the exterior or the inside means continuous. It doesn't mean that you can put something between the foam or whatever you're going to put out there. It's got to cross all framing members, right? So that is the biggest benefit for the buck, because if you take a wall assembly, and I'll show you this a little bit later, reality, if we look at, let's say this is a wall assembly back here, and we say, oh, we just put R20 in the cavities, is that an R20 wall? Not even close. If it's 2x6, 24 inches on center, it has a framing factor of 23%. 2x6 studs are only 3.5, has an R value of 3.5. The cavity might have an R20, but the studs don't, the plates don't, the headers don't, the mud sill doesn't, the box sill doesn't, right? So most of the computer generator models take that into consideration when you use the, used to be the UA, total UA result, now it's called the component. So they're measuring just thermal conduction, nothing else. And if you put some insulation on the outside of these buildings, you just knock that thermal conduction down. You can pretty much start to play with the intricacies inside the models so you can get a wall assembly that you can actually build. Because we know as builders, right, when you start to change the thickness of the wall assemblies, what happened? It's no longer 4 9/16 or 6 9/16 extension jambs. Now you're asking a window manufacturer or a door manufacturer to come up with something special. And when they come up with something special for you, what happens? It costs more. Not only does it cost more, it takes longer for you to get that product to your job site, right? And when you start putting doors on thicker walls, and you have a single swing door, and you mount it outboard, where everyone does, and the homeowner calls you up and says, hey, Kevin, I can only open my door like 120 to 130 degrees, because what does it do? It hits the inside corner of that wall, right? You think they're happy? Because when the movers come, and generally they can get the door back at 90 degrees and it cocks out, you're not going to fit that couch or that master bedroom suite or that washer or dryer through that door unless you've actually planned for it, or they got to take it off. So when we start to screw around with wall thicknesses, there's a lot of unintended consequences, right? Mass wall values, I probably won't go through that because there's not much happening here. The floor R values are actually pretty important because that's going to have an impact on our ductwork, believe it or not. And our walls, the exterior walls where we like to have to put, let's say we take up any size house, but let's say 5,000 square foot house that has everything open on the inside, because that's what we're seeing today, right? The kitchens are open to the dining areas, the dining area opens to the gathering area, the living room. Where are we putting our supplies? You know, the heating contractors are showing up and say, what do you want me to do here, Kevin? You know, I'm not using ductless mini splits. I got to duct something, even if it's an ERI or my range vent and or my ventilation stuff. Where are we going to put it? So the code has allowed a way to put the supplies, not returns, but the supplies, by building your wall out a certain way So it's the air barriers between you, that duct, and the outside, and the insulation has to be a certain percentage of that wall. You can still play around with it in res check, right? Because you can actually qualify that one little section of wall at a different U value than all the other assemblies. And you still get it to pass, but the code right now is saying air barrier and a certain requirement for insulation, and then you can put that duct in the wall. And generally, it's got to be an oval duct for it to fit inside the space that's left in that wall assembly. Slabs, I mean, here you go. That's a big change, right? You put a heated slab in it, it's R10 throughout the entire slab. Slab edge down 4 feet, the entire underside of that concrete has to be an R10, right? That's mandatory. It doesn't matter if you do ERI path, simulated performance path, or prescriptive path. That's a backstop. You can't take that one away. So the heated slab has a different condition than the unheated slab, but we're still an R10 continuous 4 feet down. And again, there is a description of what continuous insulation means. I think we all know this. R values are additive. You can add R values together and come up with this R value of the assembly, right? You can do that, but you can't treat it the same as a continuous insulation. It has to be different to comply with that table. So when you get U values, I think the difference between an R value and a U value, I'll go into this, I think, a little bit later. You know, U values include what that an R value doesn't include. You take the U value of a wall assembly, it includes the air film on the outside of that wall, it includes the sheathing, it includes the insulation, the R value that you just took the inverse of to get the U value, it includes the drywall, it includes whatever other finishes on that wall, and it includes the inside air film. That's what the U value includes. R value does not. R value is whatever stamped on that product you put in the wall, that's the only thing you can say it is, nothing else. And the code says when you put your insulation in the wall, it has to have that stamp on it. Even the friction fit fiberglass has a stamp on it. So the guys that are putting in the wall, and we'll talk about the guys that are putting in the wall in a minute here, have to put that bat so you get to see that stamp. Whether it's an R13, R19, R20, R21, R25, or an R30, you got to see that stamp. A new name, I went over it. It's because of the exposed slab. Let me see if there's anything else in here I missed. I don't think so. This is the formula behind it. That you're welcome to do that formula, but we have a chart. And that's the appendix in RF. The appendix in RF has 3 charts. There's so many charts in there I couldn't put into my PowerPoint presentation because they're so long and so small. And I think for climate zone 5, it's like the F factor for a slab is 0.44. And if it's a heated slab, it's 0.55. So there's another one of those things that doesn't make sense when you think about it, because remember, the higher the U value, the less good it is, right? So U values go to lower the U value, the better. The higher the R value, the better, right? So they're the inverse of each other. No?
What if this gravel were
No, then the code would only,
done? Keep going down?
yep,
Presume to the-
yep, correct. And Art will talk all about vapor barriers because vapor barriers are actually mentioned in the energy code because it became so important. But it really lives in the residential construction code. It lives over there in its own section, but the symmetry and the connection is so close together that they've actually put it into the energy code. Mm-hmm. Goes away. Goes away.
What about the concrete itself?
The
As opposed to stone?
goes away. The only thing you got to do is meet the intent of the code for the foundation wall. So that's R10 continuous.
Thermal mass, and the F factor goes.
Yep.
You're just taking
But you still have to treat the wall. You still have to treat the wall, right? Whether it's inside or outside. Yeah. Okay. All right. Component performance alternative, new name again. It's the same thing, but you're starting to see how things start to come together here, right? These are the specifications. This is an example building, and when you get this in a computer-generated model, if you get all the way down to the bottom right there, it'll say passes because the total thermal conduction is less than or equal to the total thermal conduction of the reference home, and that reference home lives back in 2006. Okay, so you can see how all the inputs, this is the stuff that's kind of like lives inside the computer. We don't see this, but can you get that printout for if you're a code officer? Absolutely. I would. F factor, thermal transmittance of the perimeter of the heat loss factor. I kind of went through that, but there's the formula, BTUs per hour times the square foot times the F factor. F factor is in a chart, and it was actually first described in ASHRAE 90.1, 2010, but was finally recognized in the residential world. And that F factor has been, I think it came in all because of a free download you can get, and it's called Therm. And Therm can measure the heat loss in concrete slabs. And it will show you that it actually is substantial. I just came from Boston at another conference, and there's people are refuting this now, so who knows? Code cycle is only 3 years, right? For some reason, New York State likes to take 5, and that's why we're getting these massive energy reductions all at once. So we actually suffer because of it. I mean, let's be clear, right? If they're going to gradually start to reduce the code and keep us on that glide path, it's not bad. That chart that I had and Chris had, right, 7 to 8%, yeah, we can do that. But when it gets to be 17 to 20%, we're using different materials, we're designing our houses different, and we're installing them differently, right? So it does make it harder on builders. Res check, right? This is it. It's got the 2025 drop down in it. It also has, and for you code officers, I'm sure you know this, but if you don't know it, it has a checklist you can print out. So when you go to the job site, you should have that checklist with you and just check those boxes, and you got it. Or you hand that checkbox list to a HERS rater or someone who you approved to do the ERI path. I can't imagine why anyone would want to not go the ERI path. It just boggles my mind. We're doing the same testing. You got a third party. So if a homeowner calls you up in the middle of the night and says, hey, I have air quality issues here, there's mold growing in my daughter's bedroom, you got a third party that said, when you turn that key over, this is a life cycle assessment, A1 to A3, right? Called cradle to gate. And this is critical for builders, right? When we turn that key over, we lost all control of that house. Everything that lived in that computer model, everything that we built, we put in the homeowner's hands. So unless we educated that homeowner on doing things like, don't bring a humidifier into your daughter's bedroom just because she's got some type of asthma or something or has a scratchy vote. Don't do that unless you know what the relative humidity is in that room. If you're already at 50% and you're going to crank it up to 80%, yeah, you're going to see the condensation on the glass and you're driving moisture into that wall assembly. And you will, if you have a dresser pushed up or a bed pushed up tight to a wall, you have the potential of having mold-like substances appear in that room that you had perfectly manufactured inside this computer model, put together, and the homeowner just turned it all off. So education is key, but having that third party say, when I left that house, I tested to ASHRAE standard 62.2, 2018, and the mechanical ventilation was perfect. You have that document. The code officer has that document. So if something else happened there, it may or may not have been the builder's fault or the code official's fault. And they're different amount of points for different climate zones, which they should be, right? Do a 2.5% reduction in climate zone 4, well, I guess it's 1 all the way across, but start going down there. Look at the 30% reduction in total conduction 8 in climate zone 4, 11 in climate zone 5, 12 points in climate zone 6. You can say, well, I'm in climate zone 6, I'm going to go for that one, I got 12 points. Well, you still have to pick another one. Got to have 2 categories, and if you're over 5,000 square feet, you need 5 more points, so that means you need 3 more points, and you got to choose. And it's up to you, as the builder or architect or engineer, to choose this. Don't let the architect play around with res check without you guys as builders knowing what he's checking off here, because you have to do it. You have to do it. It's not a should, it's a shall. Glass options are in there, but I don't know, you can see down at the bottom where the gas furnaces options, they're in there, they're not available because you cannot mess around with appliance standards. They're protected by the federal government. Whatever the federal government says the standard is for that forced air furnace, you can't make it any more efficient. You can't say it in the code. You can do it, but you can't say it in the code. Yeah.
There's a bunch of other.
Yeah, it takes up, I think, 2 pages in this book. But for brevity here, that's it. So here is in writing, what it says in the code book is what I'm saying, right? So R408 is actually down inside the code book. It's more towards the end, right? You got to go looking for it. So here's house was first LEED certified home in New York State or Northeast, I can't remember, that we built back in 2004. And we were looking to reduce things. And the biggest thing back then when we were preaching about, green building and it's better and people are saying, no, it's not. Well, I could say, well, back to the people who are saying, does it cost more to build green buildings? Does it cost more? Because everyone out there says it does. Well, I said it depends. Because if you reduce the thermal conduction by only putting headers in where they actually have to carry a load, you go to, in this case, I went to the metric, 19.3 inch on center, or plywood 4x8 sheets still work, right? So I took out 88 studs, 14 headers. I'm showing this picture because the window on the right is half the size of the window on the left, but it's taking the roof load, right? It's got 2 trusses sitting on it. The one on the left is a gable end. There's no weight on it at all. You don't even need a header there. All you need is something to nail your trim to. That's it. There's no weight there. The truss takes that load. So let's say we took out 88 studs, 14 headers. I saved $458. Again, this is back in 2004. Go to your framing contractor and say, hey, that's a lot less work. You know what they say to you? This is different. I got to use a different ruler or whatever. So they don't give you any credit on it. But there's the studs that I took out. Because people can't see it unless you show it to them a different way. That's over 100 square feet of R3.5 I took out of that wall assembly. And what did I put in its place? R20, right? That's a big boost. Interesting thing on this one is I think you guys know in the trades, right? The insulation contractors, at least back our way, they just count sheets of plywood, comes up with their number, bids the job, and well, I got 100 square feet of insulation for free because he didn't catch it. He never caught it until he came to one of my presentations and saw me show that slide. And then he started to change his bids a little bit. But that's what it looks like. And the bigger thing, I'm a biologist who became a builder, so for me this is important. 2004, there were 1.9 million housing starts, and when Emerson said, talks about the housing crash back then and what really happened, we went from 1.9 million housing starts in the U.S. to 86,000. That's more than a crash, right? But if you take that 1.9, I actually did the board footage calculation on this and the 14 headers, right? They have over 30,000 acres of forest preserved each year, and what do the forests do today? Everyone says plant trees because they're actually recycling carbon dioxide for free, right? They breathe in the carbon dioxide, they split the carbon away from the oxygen, they put all the carbons together on a chain and puts the oxygen back out in the atmosphere for us to breathe, keep the 19% oxygen in there so we can actually stay alive. And what do the long carbon chains give us? Because they're seeing it right now in the trees, right? Days are warm, nights are cold, the maple sap starts, it's the sugars and starches that are giving it to us for free. So planting trees does make a difference. Tupper Lake on the left. Zero energy house, all electric on the right. Tell me where the air barrier is. Where's the break on the left? That's good. I mean, you tape it up, you got it, you did your inspection, it's good. Easy to see. Yep. On the right, easy to see, easy to find. Not on your life. 4 inches of wood fiber insulation on the outboard, continuous. Vapor open assembly, because let's start thinking about what's going on with our buildings today. We start to say vapor open or vapor close. We just moved 8 counties out of climate zone 6 down to climate zone 5 based on heating degree days alone. Nothing else. What about torrential rainstorms? What about everyone going to put air source heat pumps or geothermal systems into their house? And now we're going to start, I don't know, if you have an air source heat pump on your house and it's 80 degrees, you think they're not going to turn it on? The people who never had air conditioning before, of course they're going to turn it on because you got cooling and heating in one unit. And it has a COP of about somewhere between 2.8 and 3.5. So every bit of energy you put into an air source heat pump, you're getting out anywhere from 2.8 to 3.5, which of energy coming back at you. Just by taking the heat and cool from the air, right? But when we do that, when we air condition our houses, where should our vapor barrier be? Let's say it's 3 months and a month each side on the shoulder sides when it's on. Because you go down south, hot, humid climates, right? Where's their vapor barrier? Yeah. We're on warm in the winter side, up here. It's the code. It tells you got to do this. So what's happening? 5 months, maybe 4, maybe up here only 3, but down where I'm in, it's 5 or 6 months. Our vapor barrier is on the wrong side of that assembly. Where should it go? The code tells us what it has to be. Class 1, 2, or 3, it's defined. We know what it is. We know what the code's telling us. What should the builders do? There. Yeah, that too. But there are smart vapor barriers that allow this to happen. Because when you start thinking about the day, we had 2 weeks ago a delta of 70 in our temperature, right? The nighttime temperature to the high in the daytimes was 70 degrees difference. If you think about that and you go down to Florida and you come up here, or you go down to the Virgin Islands and come up here, we just went through every climate zone that EPA designed. And it went through our wall. It moved through our wall assembly, whether it came in or whether it went out. And we need to know where that moisture is going, because that's where all the bad stuff happens. Whether it's a vapor, liquid, or God forbid it freezes, right? Some of the biggest calls we get today, I mean, it's unbelievable. We get a winter like we got now, ice dams occur, they got in there, they froze, right? And then a week later, all of a sudden the temperature goes up to 55 degrees, and you get a call from someone that says, Kevin, you know, it's raining inside my house. It's not raining outside. We didn't have this leak in the winter. What just happened? Water went in and froze. Went up to 55 degrees, it melted, and it starts coming in. Well, that water is in there, and we need to keep it out. The smart vapor barriers work more just, I mean, we're in the North Country, so we all know what Gore-Tex is, right? All know how Gore-Tex works, right? And in high school chemistry, we learned that H2O was H2O. Is that it? That's all we need to know? H2O is one molecule. It's the smartest molecule on Earth. It's the only molecule that expands when it gets cold. Nothing else does that. It can lift houses. It can crack massive boulders in the Adirondacks. We know this, right? We know the power of water when it freezes. So how does our buildings should work? Gore-Tex works by, it allows water in a vapor form, H2O, out through these tiny pores, but it stops water as a liquid, which is 180 over 60 or more, because water have strong hydronic bonding. That molecule is always at 104 degrees. It's the only molecule in the world that has that. And it's going to grab another molecule of water because it attracts it. And it will grab a water molecule and lift it up and bring it up. So when the plumbers say water only travels downhill, don't believe them. It can come uphill. But if we know that we have smart vapor barriers that have relative humidity anywhere from 50 to 60, it's like our cross-link fibers in our canoes, but these are made to open up. It senses the relative humidity, and it opens up, and it releases the moisture. Oh, I wish my grandkids weren't here, because I'd say another word. I'm a builder, right? I work with a hammer. But that's it. The smart vapor barriers save us. Whether we have the air conditioning on or the heating system on, it doesn't matter. Our wall assemblies have to take both. And if we have a smart vapor barrier, now all we got to do is just make sure we install it per manufacturer's instructions, right? Because we're not seeing that. So easy to see the air barrier on the left, hard to find it on the right. When we have to go and do the air leakage test, it can be anywhere. Not where we think it is. It's certainly, I would say there's 80% chance it's not where that architect drew that red line around all 6 sides. Because remember, the air barrier has to be on all 6 sides, right? Where is it on our ceilings? The drywall? Where's the vapor barrier up there? The paint? Class 2? Intello? Membrane? Smart membrane? We got to start to know this to understand where the moisture goes, because our house fails because of moisture. Biggest failure rate of everything. Yep. And so there's vented, where we vented at the bottom, and there's ventilated. Ventilated means that if you take that siding and separate it from the sheathing, and it only has to be like a 3/8 of an inch, you just let the air go through there and you let the moisture go out. And what you just did, if you have your siding right against your sheathing and you have moisture in there, it's going to push the only way it can, and that's what pushes the stains and paints off your siding. You separate it, you just equalize the pressure differential between the outside and the inside, your paints and stain are going to last a lot longer. Oh, here you go, code officers. Mandatory. Shell. You've got to test the mechanical ventilation. It's got to meet ASHRAE 62.2, or it's got to hit that chart that's on page, 97 of the code book. And the only reason that the code officials gave you a chart is because the code cycles every 3 years. ASHRAE can change anytime. If ASHRAE changes before the code changes, you got a mismatch. So there's a chart inside that book that you can go across to the square footage, and you can go across to the number of bedrooms. Remember, it's the number of bedrooms plus 1 for ASHRAE 62.2. For whatever reason, there's always 2 people in the master bedroom and a person in every bedroom in the house, right? But so I would use the chart. Make sure you're there, and I would always check the technical bulletins that are released by the Department of State. Always check them before you do your plan review. Get the newest and best things out. And you got to have a timer. You got to have it. It's in the code now. It's mandatory. It doesn't matter if you do the prescriptive path or performance path. You got to have someone come in with a piece of equipment. The piece of equipment on the right is $5,000, and you got to be certified to use it. It's wireless. You Guy on the left is me, that's a cheaper one. It's still $1,700 and you still need to know how to use it. Most people don't. It's not just hold it up there and read it, and it's got to get calibrated every year. So you got to pay the $1,700 and you got to get it calibrated every year, or whatever what the manufacturer tells you, right? And that goes with all the blower doors. You got to check the fan, you got to put a ruler across it, you got to calibrate your manometers, and if you can't calibrate, you got to send. I just sent mine 2 away. It cost me $570 for a GG1000 and DG7. I sent it back to the Energy Conservatory because I wanted to make sure mine got calibrated right. And I had 3 calls from other raters already. Can I use your manometer to calibrate mine? You're allowed to do that, but unless they put it in the lab, you really don't know, right? So you have to do this. Is a code official, do you own one of these? How many code officials in the room? Brian's back there, right? Do you have a barometer test this? There's no way. Can your municipality afford to buy you this and train you on it? Not going to happen, right? Who's going to do it? We're back to these guys in the back room. Those 2 guys will do it. They know how. They own the equipment. They're paying the $1,700 for that. They're going to come in and measure it. Because they're third party, you can rely on those results. They're not going to fake them. They're going to go in and do that work for you. They're not just going to say, oh, the fan says the fan motor number on the model says you're exhausting 70 CFMs. You can't do that anymore. You got to test. Mechanical ventilation has to test. That's in the code. I'm glad you brought that up, Art, because Monday morning, I mean, get this. This is a little bit broken system, right? I did a house over a year ago. And I put it in for Energy Star for a LMI builder, low to medium income. So I did it as a freebie, thinking I'm helping them out. It took me like, I don't know, 7 trips. So I've got 7 trips, 9 an hour, changed my hourly rate. I got a lot of money into it. Plus I have all the equipment. Plus I did all the computer generator models for them. I put it in. It triggered like 1% in-person QA. There's somebody flying in from the Midwest to meet me Monday morning to test my house, and this guy has 3 years experience, and then he's going to fly down to Florida, and I have to pay for those flights for my QA. And if I'm wrong on that house, yeah, it's a big another bad word moment, right? So you better believe we do it right. We do not fudge numbers, whatever it is. If you fail, you fail. If you pass, you pass. If we're saying you're passing by too much, like you got a air leakage result of 0.06, like a passive house, and your mechanical ventilation isn't tested properly, you're in trouble. The code official's in trouble, the bill's in trouble, the homeowner's impacted. Not in a good way. So you got to measure it, and this is what it looks like. If your kitchen rain, there's one small exclusion, and I canvassed the builders in our area. I go, how many can you put a ductwork in that's 6 inches or greater, less than 10 feet in length, and only has 290s? Most of them goes, no way. Better make sure that exhaust fan's working, or the whole apartment complex is going to be on it. So it's hard. It's not easy to do this. They actually make a fitting that fits that exhaust fan, because if you're on the 5th floor, you can't go outside and measure from the outside. You can do it maybe floors 1 and 2 at the exhaust vent, which we're allowed to do. Most of them have to be measured on the inside. This is in the code right now today. As of the 1st of this year, we have to measure the mechanical exhaust and the range exhaust. And it has to hit a number. This is actually one of my favorites. Same project, right? That's the code officer for the city of Rome. And he came with me to every single unit. If there was 79 or 83 units, he came with to every single one. He goes, Kevin, I want to know about this air leakage stuff. So it's the code officer for city of Rome, and he understands what an air leakage test is. You know, we're not just depressurizing to minus 50 pascals. That's a DG 1000. So he knows what he's doing. He went around and he felt it, and I gave him my smoke pencil, so he knows where the leakage is. And he knows when it's coming from a bad spot now. So he knows how to interpret what the 3ACH50 number really means. And the woman on the right, single mom of 2 young kids, lowest paid person on the project, right? Putting insulation in all day long. I went up to her one day, I go, you know, what you do has an impact on your kids. You're probably the most important person on this project. So when you empower someone like that, she not only went to being so critical about how she's putting fiberglass bats in, within 3 months she was a supervisor of the installation crew. She didn't have to physically put it in anymore. She was the QA for a large company that's based down in Saratoga, I believe. She knew that getting itchy all day actually makes a difference, right? A big difference. So there are mentorship opportunities and allies, right? 3 guys, I mean, the big job I'm talking about in Syracuse, there's 350 people on that job site every single day. I think we're making them better at their jobs by telling them how important they are. Because it's not just here in Central New York up on Syracuse University's campus. It's over their next job's in Colorado, right? But if we can just tell them how important their job is, because the better they do the insulation, the more energy the house is going to use from now until its entire life, right? And this is all about energy reduction. They have the most important job. Not the architects, not the engineers. And everything that we see in our houses today that breaks, I can say that 90% of it isn't the technology, it's not the product, that's just physical. It's us. It's the installers. We do it wrong. We need to incentivize these people to do it right. Because if they do it right, the energy models actually do work. Here's the equipment. Every code officer has to have this piece of equipment unless they designate a third party, these guys in the back, right? And this is what it costs. A blower door kit. You might as well say it's $5,000 by the time you get it here. A duct blaster, $4,000. Cheapest one you can get, unless you know, some people do use the anemometers, they stick in there, but they're not accurate. So you might as well say you got $12,000 worth of tools that 6,000 of them you never had to have before. It's in the code right now. Code officers have to do it. If you don't want to do it, you better hire someone to do it. And the person that does do it better know what they're doing and better calibrate their manometers and this equipment. Every year, you've got to get this stuff tested. And a duct blaster test is not an easy thing to do. It is not. I just threw this in there for heated slab edge. You know, sometimes there's easy ways to do it, right? If you're just going to start to do this on a concrete stem wall that comes up and it's 8 or 10 inches wide, it gets a little difficult where the doors are, right? And you say, well, I'll just get an ADA compliant sill extension. Yeah, put that over foam and tell me how long that lasts. Because it doesn't. So we came up with this. We pour a little stem wall instead of the wall. We actually just form it out, and we form it out inside the forms. We just put the insulation right in so we don't have to do extra work. You can see we got our 2 forms. We got a 2x4 stud wall that boxes out the insulation. So when we pour that wall, the door sits right on top of it. And it works. And you met the intent of the code, and you didn't screw up your door sill. Fenestration criteria, U factors and solar heat gain coefficient. What does solar heat gain coefficient means? It means in this case, if you have a solar heat gain coefficient of 0.71, it's 0.71 of that long wave radiation makes it through that window. That's all it means. That's all it measures. Low E coating up here, you know, when we had COVID and before that, some of the housing stuff going on where the housing bubble burst and the financial world was in trouble, we were getting Energy Star windows. The builder was saying, yeah, I got an Energy Star window. It's stamped right there. Well, they never looked at the lower part and go, that is an Energy Star window for southern climates. We're getting windows over COVID that were turned around. Had the emissivity coating on the wrong surface. Up here, where do we want it on our surface? It goes like this, outside the inside. Surface 1, 2, 3, 4. We get to tell our window manufacturers. Cardinal Glass up in Canada makes like 75% of the glass for the entire country. You can tell them what you want. You're going to wait a lot longer, but you can tell them. You can say where you want that emissivity coating placed. In the commercial world, it's on the outside. In the residential world, it's always inside the glass because it's a soft coat, meaning that if little kids come up and scratch it, you're going to impact the coating. So it's always on surface 2 or 3. Let me see if I can get this going. Here was one of the biggest projects that we worked on that had passive house windows installed, watching the lower right corner of the operable window. Ooh, right there, you see it?
Yeah, it's good.
This place wasn't even to a point where it was, EFS wasn't even finished on it yet. And they had so much condensation on the windows, it filled the sill, an inch of water. So we got called in with guys like Terry Brennan trying to figure out what's going on here, how are we going to fix this? Well, what was happening with the window? Well, this is a COVID job. Pardon me?
Play it again.
Sure. Look at the the lower left corner of the operable window. And you can't find this stuff unless
Yeah, it's good.
So we smoked the entire dwelling unit in this case. But we had to do them all because we had to find out what was going on. And we traced it back to when you have a really good window, you may increase the condensation potential of that window. Cardinal glass 15 years ago had 481.0, and they wouldn't release it to the world. It's the best glass at that point in the United States. I'm sorry, it was a Canadian manufacturer. In North America, it was the best glass out there. They wouldn't release it because of the condensation factor. What did they care about? Callbacks. People complaining I have condensation on my window. It's out there now. And this is what we get to look at. We've got the U factor, 0.28. Oh, prescriptive, doesn't meet the code. Performance, sure it does. Solar heat gain coefficient of 0.3, right? We know a climate zone 4 and climate zone 5 have a prescriptive value for that. Visible transmittance, but oh, look, bottom right corner. Condensation resistance. Someone says condensation potential. So that sticker is critical, and it's the only accepted standard out there. If you don't see an RC sticker, you got to go to the code book and you got to take the default, and the defaults are very, very tough. Reduction in total conduction. I mean, this is continuous insulation, right? It's rock wool bad on the exterior of this building. Again, this building has 1, 2, 3, 4, 5, 6, 8 sides to it because it has a courtyard in the center of 7 stories. It can't. Okay, this is an old one in the code, but it gets to be more critical now because of what the prescriptive measures have changed with ceiling insulation, right? I'm going to read this. The design does not allow for a prescriptive R value or whatever that computer model generated. You can actually go down to the next level. So if you're going to do the prescriptives, let's say you're in res check and it says you have an R49. If you have an area like this, you can reduce it as long as that insulation goes out the entire area of that top plate and hits the outside uncompressed, you can reduce it. If it gets compressed it off, you don't have an energy truss or a raised seal truss, you can't do that. It's no, not that. But if it's uncompressed, because the minute you compress insulation, you reduce the R value. Every insulation product out there today works by one simple thing. It captures air spaces, right? So fiberglass has fibers that are woven together, creates little air space in it. Spray foam, same thing, little pockets of air. So it reduces the conduction of heat movement across the surface. Heat only moves 3-way, and if you take conduction out, that's the biggest one, right? That is your hand touches a hot pot and it burns. That's conduction, right? Radiation is when you stand with your face in the sun and you're warm and your back is cold, or you're standing in front of a fire, right? And then there's convection. So it can move by convection across those little tiny holes. But if you stop the conduction, you're doing something good. So you're only allowed to do this 500 square feet or 20% of the total insulated floor area. So I don't know what code officer is going to go out there and start measuring and doing the math on that. Code commentary actually says you can have an informed guess by looking at the area, right? If design does not allow, I just said this out loud, does not apply to the component performance. You can't use this in the U value. Remember, U value is computed differently than the R value. So it can only be used in one of those drop-downs in the prescriptive side. That's it. These are just raised steel trusses. This has, I believe, in Tullo on the inside. Another one does. I threw this in at the last minute because when we, as HERS raters and Energy Star projects, we fail so many townhomes. And even, you got to do the 3 ACH 50 in a townhome too, right? It's single family, 2 family, 3 stories or less, you got to do it. And you go in there and the builder always says, I hear it over and over again, well, no one told me I had to air seal between units, so when we put the blower door in one unit, we're measuring the air of the other unit too, because they're not air sealing. That's critical that it has to be done. You can also see, if you go back here, you can see, you know, where's the insulation? The frost lines tell you. You guys know how to read roofs, right? You come back on a cold day after the frost hits, you can see where the insulation's failing. You can see the thermal bypasses. The natural world's telling us where they are. Eve baffles are important. This is a real picture. The other thing about this picture that's pretty alarming, it's a class 1 vapor barrier on the ceiling. It's polyethylene, right? What do you see beaded up on the polyethylene? Can't say it, but you can see it. So the air baffles stop the wind washing coming up through this soffit fence. You get these windy days, these high wind events like we're getting. It blows the insulation back, and then we get the big icicles, right? Wood frame walls. So an attic D wall is a wood frame wall. It's got to meet the intent of the prescriptive code or whatever you did in that model. Whatever you told that wall assembly had to be, it's got to be it. And what does that mean? Air barrier, the unconditioned side. So you can't have a truss that's separating conditioned from unconditioned space. You can't have a knee wall that's separating conditioned from unconditioned space unless there's an air barrier on the outside. How does that insulation work again, right? When you test it in a lab, it's hermetically sealed on all 6 sides. They just measure the temperature, how quick it moves through the assembly, and they do it. If you don't have an air barrier on the other side, you just lost all that insulation R factor, right? So you got to meet the same conditions of a wood frame wall and an attic knee wall. And you have to do it on the wood truss as well. I said earlier that, you know, with an exception that, you know, most of our air leakage does come in from the garage or underneath our decks down low, but, you know, the simple physics is, and this is the second law of thermodynamics, right? Warm air goes up. So the thought process in the really good weatherization crews, if you stop it at the top, you put a real robust air barrier in, what's going to happen? Nothing's going to come in at the bottom. 1 air in equals 1 air out. If 1 air can't go out, 1 air is not going to come in. That's a simple law of physics, right? Stop it at the top. So when you do these existing homes and stuff, or in the new homes, your best benefit is stop it at the top, then go to the basement, and then do your sidewalls last. So the attic hatches and doors in the attic spaces are treated. I would say that that is probably the most important door you have in your house. You might as well say it's important as your front door. And when you put just drop a sheetrock into a framed assembly and throw fiberglass insulation on the top, would you allow that to be your front door? Absolutely not. You want to go into some of these older houses and look directly above where that attic hatch is, that's what we see. The air is leaking out. Warm air is leaking out. Warm air holds more moisture than cold air, right? So it's taking warm, moist air, hitting the underside of the ridge, and you either see roof nails that are starting to rust or dripping, or you see this where it's very obvious what's happening, right? So in this case, you can buy these assemblies. We just take double hung window hardware, put it in, put rigid foam on the top of it. Now we're actually putting it up higher. You got to have your retention around it. So if you need an R49 and blown cellulose in there, so you want the prescriptive path, your retention around those attic scuttles have to be this high, right? You gotta take that 17 to 21 inches of cellulose or whatever it is. And then what I don't have in this one, those holes aren't made just for code officers, right? They're made for firemen and everyone else to go up through it. You don't have to go up into the attic, but you have to lift that attic scuttle, slide it over, and they have to put little rulers around every 300 feet that you get to see the insulation level. You don't have to go and measure it. They have to do that. And then they have to sign a certificate that has to be posted in the mechanic room that says, I blew 30 bags of 3.5 density cellulose into that attic. And what do we know when we know that number? What's it tell us? 30 bags has a certain coverage, right? So they have to say that and they have to sign it. They have to physically sign it. Either the builder or the guy who did it has to say, I did that, here's how much cellulose I put in that attic. 'Cause I can't tell you how many times we go up in that attic and you see everything's perfect, then you walk down a couple truss bays and you see all of a sudden it starts to diminish, right? So they're telling you, and they also have to give you the rated value when it's settled. So there's no more in the old days and after the 70s when we're putting our thumbs out like a garden hose and you could fluff up the cellulose, right? Can't do that anymore because we have to give the settled R value and it has to meet the intent of what you guys did on your planning review, right? It's got to say it. Here's an example, just component performance alternative, right? Here's a simple example. If you have 990 square feet of an attic insulated to R49 and 10 square feet of it, that's a pull-down stairs size, that is a pull-down stairs insulated to R1, which is giving it a lot of credit, what is the average R value for the entire attic? So right here, we're just going R value to U value, just doing the inverse. Go. Fire assembly, the UA, or component thermal conduction approach, knocks it down to 33. That's how important attic hatches are, right? And you know the first time somebody goes up there for that's fiberglass on it was glued, sticked on, taped on, or whatever, it doesn't make it back down the second time, right? And the guys who are doing the caulk around it, because the code says you got to seal it, once you break that caulk, it's gone, right? The homeowner's not going to put it back. The IT guy's not going to put it back. The heating guy's not going to put it back. And oh yeah, by the way, the heating guy shouldn't have to go in the attic anymore, because guess what? You're not allowed to put ductwork in the attics anymore. You can't put ductwork in conditioned space unless there's rules. And they're very, very specific. And I'm going to go through that in a minute. But hold that thought for a minute. No more ductwork in the attic space.
2 minutes.
Stop at 11:30?
Yes.
Oh, I'm going to hurry up then. Vapor retardants, Art's going to cover that. I want to show you this one real quick. That was a fire alarm fire. $800,000 house, just had $72,000 worth of roof on it and $30,000 of insulation. Got a fire? Moisture. Fireman came in after another call, had soot all over the boots, walked over the white carpet. One guy had an IR camera, heat sensing camera. There's no heat up there, it's not a fire. So our move was over on the right, cut it open, see what happened. 6 months. What they do, they took fiberglass insulation out because everyone says it's no good. Had a vapor barrier on it, craft face, right? They put open cell foam back, covered it up, took the vent out because now you had it foam sealed, right? So what did we have to do to fix this? And it was a big lawsuit. It wasn't a small one, right? There's $300 worth of mistakes right there using open cell foam that doesn't stop vapor. Open cell is not a vapor retarder, right? Closed cell, yes. Open cell, no. The other one, I'll go by that one because that one's even worse yet. Here's some of the smart vapor barriers. CertainTeed's made them for 20 years now. Membrane is called. Intello. All this stuff is on the market, readily available right now. Intello, most of the guys in Passive House wrap it all the way up and around the ceiling and back down the walls. what we usually see when we're out looking at stuff, right? This one was approved for drywall on the left. We do a lot of zonal pressure diagnosis with IR cameras. You can see the big miss here on the left. Blower door, you got one right out with the 55 guys. They can show you this, so I'm not going to talk about it. Energy code sets the target, but the national standard sets the methodology. Unless you're trained on these things, you shouldn't be using them. This is what the letters we write. Temperature, wind, CFM result, whether it's a temperature correction factor. Golly, this winter we were doing a temperature correction factor that went all the way from 0.947 down to 0.902, I think. Yeah, you got to do a correction factor. You just can't take the reading off the micrometer and say, hey, it's 3 ACH 50, you pass. It's corrected by weather, because when you have a cold day versus a warm day, the air density changes, and it changes the reading, but you got to do that. This one, duct system. I got to talk about this just for a minute, all right, Jen?
Yeah,
Because this is like critical, right? I'm going to go right to this one. So, looks like we have a little bit of an issue here, but duct systems located in conditioned space. If you want to say you're in conditioned space, you better be doing this, right? So if they're going to use the attic space as a chaseway again, it's got to be buried in the insulation. The sum of the insulation against and above the top of the ductwork is greater than or equal to the proposed ceiling R value. And subtract the R8 off of this duct because it's bigger than 3 inches. It's only got to be R6 if it's 3 inches or less, right? So it's got to be buried like this, but what else do you have to do? You got to test it. You got to test it with a duct blaster. And now you're not just testing total leakage. Total leakage means you set up I showed you what the duct blaster looked like. You're only blowing 25 pascals into it, and you're measuring the leakage that's coming out. You put the ducts in the attic like this, you got to do total duct leakage to the exterior. That means you got your code officers, got to set up a blower door, pressurize the house to 25 CFMs. That's a big thing to do, trust me. Then you got to cover every duct in the house and seal it, and put this duct, let me go ahead here real quick. I think I have it, I can show you. And you got to seal up all the ducts in the house, and you're blowing 25 CFM. It's not an easy thing to do again, I'm telling you, it's not. And then you got to measure the leakage to outside, and it can't be more than 1.5 CFMs for 100 square foot of conditioned space. And this is how we had to fix it. You don't want to be that guy. The builders in the room, you do not want to be these people cutting holes in someone's ceilings, going up, trying to find leakage in the ducts to pass. You don't want to be tracing around the attics. Trust me, you don't want to do that. So what the code world is saying out loud, get all your ducts inside conditioned space. Don't put them in the attic, or you got to do that test. And even though they're in conditioned space, you still have to test them. This is the simple stuff about 3/4 inch pipe. You got to have the insulation. This is an HRV for those of you guys who are familiar with it. It's what they look at. The airstream never crosses. We just had a big job out in Colorado come and say, I can't do that because I don't want to mix the air. They never mix. They never cross. They're going through a filtration system, which can be all the way up to a MERV 13, which means we're actually taking 2.5 microns of particulate matter out of the air. So if the smoke comes again, they do have filters in them. Building Excellence Project, right? So third-party testing, performance testing, finds these things before they become big problems. There's the chart. There I am measuring it. I wanted to go backwards, not forward. There's the chart I said you can use, it's in the code books. You got mechanical systems outside the thermal envelope. These are real pictures. I can't make them up, right? The snowball system calls this. Didn't solve it, it calls it. So you need controls on it, and those controls have to meet that. Very robust. Very robust. So simulated, I think I covered that earlier, but here you go. Dwelling units with one or more fuel-burning appliances, right? Space heating, cooling, mechanical ventilation, and water heating only, that's all it measures for the cost. And if it's gotta be that, it's gotta be 80% better if you got a fossil fuel burning plant in that house. If it's all electric, it only has to be 15% energy reduction. And if you, over 5,000 square feet, you're back up to the 20% energy reduction, right? Energy rating index, talk to those guys in the back of the room, or you can come on down and talk to Josh and I. We do a ton of these. What it looks like, a house that hits a HERS 100 is how built to code. A house that has a HERS index or an ER 0 is zero energy. And up here in New York State, we got to be in climate zone 5 and 6, 54 or 53. If you want that 45L, that hopefully does come back someday, all you got to do is hit is 50% better than code. You get a $2,000 incentive. Oh, and I should probably end on this one. How many people go into a house as a code official and see the mandatory certificate in the mechanical room? Anyone? I got 1, 2, 3. Do they list duct leakage test on it or air leakage test?
Sometimes that.
Yeah. So right now, because of now it's just not the air leakage test, it's the duct leakage test and mechanical ventilation. Those have to be on those stickers now. No stickers aren't out yet. You can get them from ICC, but they're not out anymore. Okay, so here's all the appendices. They were moved out of the code under appeal. They were in the code in 2024, and then they got moved out on appeal. And the only one that New York State adopted was the RF code. And that is because of the F factor. Okay, that's it for me. Thanks.